Assalamualaikum warahmatullahi wabarakatuh. Okay, so in this video, we are going to learn on chapter 7 in KSSM form 4, which is on graph of motions. And today we are going to focus on speed time graph. Okay, so the learning objectives in this video are, okay, the first we are going to learn on how to draw speed time graph based on the data given. And then we are going to make a relationship between area under speed time graph and distance traveled. And we are going to interpret speed time graph by describing the movement based on the graph. And lastly, we are going to solve problems involving speed time graphs. Alright, so before we go further in this topic, these are the required basic mathematics skills that we need to recall in order for us to understand this topic better, which is the first one, the formula to find acceleration is equal to speed over time taken. Okay, acceleration is pecutan sama dengan laju bahagi masa. Kemudian distance traveled, okay, jarak is equal to speed times second, laju darat dengan masa. And the last one is the average speed is equal to total distance traveled over total time taken. Purata laju sama dengan jumlah jarak bahagi jumlah masa. Alright, so let's start by drawing distance time graph. Okay, so these examples I got from textbook. Okay, from 4 textbooks, KSSM, page 185, in which in this table it shows the change of speed of Encik Azizo's car for a period of 5 seconds. Okay, so we have time, we have speed. Time from 0 to 5, and the speed is 0, 10, 20, 30, 40, 50. So based on the table, draw a speed time graph. Okay, so in order for us to draw speed time graph or any graph, these are the important steps, okay, that we have to follow. The first one is that we have to draw axis and label the axis. Okay, so in graph we have two axes, which is the vertical axis, or sometimes we call as y-axis, and also horizontal axis, or sometimes we call as x-axis. Okay, so in this speed time graph, okay, what you have to remember is that for the vertical axis it will be speed, and for the horizontal axis it will be time. Okay, so sini adalah laju, sini adalah masa for speed time graph. Speed times graph. Okay, and then the second step, we are going to choose suitable scales based on the values given in the table. So as you can see here, the values are very simple, okay, and in a good sequence in which you can see the time is, the difference for the time is 1, okay, from 0, 1, 2, 3, 4, 5, and the difference in speed is 0, 10, 20, 30, 40, 50 tenths for each second. So therefore, I already choose two boxes here. Two boxes of grid is equal to 10 for speed, and two boxes for grid in the vertical, on horizontal axis for 1 unit. Okay, dua kotak sama dengan 1 unit untuk x-axis, dua kotak sama dengan 10 unit untuk y-axis ataupun untuk speed. Okay, so we already choose the scales, and the third step, we are going to plot according to the table. So as you can see here, we have 0, 0, 110, 220, 330, and so on. So we plot all the points. Okay, we have 0, 0 here, and then 110, 220, 330, 440, and 550. Okay, so once we already plot all the points, and lastly we are going to join the points using ruler, because for this graph we are having a straight line graph. Okay, so just follow these steps in drawing any kind of graph, okay, especially for this topic which is on speed time graph. Okay, so now what is the quantity represented by the gradient of a graph? Okay, for this one we have a speed time graph. Okay, so as you can see here, as I told you before, the quantity on the vertical axis is the speed, and the quantity on the horizontal axis is time. Okay, so if we recall back, gradient will be equal to change in speed over change in time. Why is it so? Because as we recall, okay, the formula to find gradient which is m is equal to y2 minus y1 over x2 minus x1. So here y2 minus y1, y-axis kita adalah speed. Okay, so y2 minus y1 means the change in speed. Okay, and x2 over x1, here our x is time. So when we minus the value of x2 minus x1, we actually get the change in time. Okay, so therefore we can conclude that the gradient for this graph is equal to change in speed over change in time. And as we recall back the formula, we know that the quantity is actually represented by the gradient is the rate of change of speed. ataupun dalam bahasa lainnya adalah acceleration, pecutan. Rate of change of speed sama juga dengan acceleration. Okay, kadar perubahan laju adalah sama dengan pecutan. So actually the gradient for this graph means that we are going to find the acceleration, or if we get negative values, that means we are going to find deceleration. Okay, so now we are going to describe, okay, the motion or the movement of the car travels from point P to point Q from this graph here. Okay, so as you can see here, from A to B, okay, the graph is ascending, okay, from speed 0 going to speed which is, we don't know the values, but it is increasing in speed. So section A to B indicates that the car is moving with constant acceleration. Okay, there is acceleration happening there because the speed changing from 0 to a higher value. And then as we can see from B to C, there is no changes in speed. Okay, speed dia kekal sama, remain constant. So that means from B to C, it indicates that the car is moving at constant speed. And then from C to D, again, the speed is increasing. So C to D indicates that the car moving but at a slower constant acceleration. Why is it slower? Because as you can see here, gradient of CD is less than gradient of AB. Okay, kecerunan CD lebih kurang daripada kecerunan AB. Therefore, the acceleration will be slower. And the last one is from D to E, from a high value of speed going down to 0 speed. Okay, here the speed is 0. So that means it is an acceleration. From D to E indicates that the car is decelerating. Nah, pecut daripada laju menjadi perlahan. Okay, so this is how we describe a speed time graph motion. Okay, so now the quantity is represented by the area under the graph. Okay, under a graph. Okay, so let's see an example here. We have a train travels at a uniform speed of 70 km per hour for 3 hours. Okay, moving with constant speed or uniform speed for 3 hours. So if you want to find the distance, as we recall, distance is equal to speed multiplied with time. So here the speed is constant, so there's no problem for us to find the distance, which is, we just substitute the value of speed, which is 70, times time, which is 3, and so we get the distance is 210 km. Alright, so if we transform or we represent this situation into a graph, okay, graph of speed time graph, so then we will get this kind of graph in which the speed is constant for 3 hours. And so if you find the area under this graph, in which the purple area here, we get, okay, this is a rectangle, so to find the area will be 70 times 3, which is 210, and 210 is actually equal to the distance as we already calculated before. Thus, in a speed time graph, the area under the graph represents the distance traveled. So area under the graph is represented by, represent the distance, and the gradient for speed time graph represent the acceleration or rate of change of speed. Okay, that's the two values that we have to know in speed time graph. Okay, so to find the area under the graph, this is the things that we have to recall, that we have to remember, which is because the area under graph for speed time graph, okay, involves objects such as rectangles, triangles, and trapeziums. So kena ingatlah formula to find the area for these three types of polygons. Okay, alright, just a quick recall. Okay, as we already learned this during our secondary school and primary school. Okay, alright. So for examples, let's find the area under this graph. Okay, as you can see here, what are the shapes involved in this graph? Okay, as you can see, to find the area under the graph, the first shape that we see in the yellow side here is actually a trapezium. Okay, and then the area, the second area, which is the green color here, is a rectangle. So area of trapezium A plus area of rectangle B, and the last one we get here is actually a triangle. So to find the area under the graph, we are going to sum all the area of trapezium A, area of rectangle B, and area of triangle C. And by using the formula that we already recorded just now, to find the area of trapezium A, 1/2 times 15, the length here, plus 25, the length here, times 10. Okay, that's the formula to find the area of trapezium. Plus area of rectangle, very easy, which is length times width, 20, which is from 10 to 30 is 20, and then the height is 15. And the area for triangle is 1 over 2 times the base is 10 and the height is 15. And so when we calculated all this value, we'll get the answer is 575 units squared. Okay, other than that, using the same graph, actually we can see that we have the shape of trapezium A, and also the rectangle and the triangle just now can be combined as a trapezium. So area of trapezium A plus area of trapezium B will also give us the same answer, in which using the formula to find the area of trapezium, 1 over 2 times 15 plus 25 for the first one times 10, and for the second trapezium we have 1 over 2 times the parallel lines here is this one, which is 20 plus the bottom line here, which is 30 times the height here, which is 15. Okay, so when we calculate this, we get 200 plus 375, and also we'll be given the answer 575 units squared, which is the same as the previous example. Alright, so let's see some examples on the speed time graph questions. Okay, the speed time graph shows the journey of a car for a period of 1 hour. Okay, so now we are going to calculate the distance travelled by the car at uniform speed. And the second question asks us to find the total distance travelled by the car. Okay, so let's see. The first question asks us to find the distance travelled at uniform speed. So where is the uniform speed? Here, the uniform speed is this region. Okay, the pink color region. So it is the distance. To find the distance for speed time graph, which means that we have to find the area under the graph. So the height is 30 and the base or the width is 10, but as we can see here, the time given in the graph is in minute, but the speed is in kilometer per hour, so we have to change the minutes into hour. Okay, make sure in this topic be careful with the units. Alright, look at the units first, and if you have to change, you have to change the units, especially when it is involving the time. Okay, so when we calculated this one, we get 5 kilometer. So now we go to the second question, which is we are going to find the total distance traveled. Total distance traveled, that means we have to find the total area under the graph. Distance sama dengan area under the graph. So the first object is trapezium, the second region is B, which is rectangle, we already find just now, and the third one is another trapezium, okay, which is trapezium C. So now to find the area of trapezium A, using formula 1 over 2 times the height, times the sum of parallel lines, which is 30 plus 70 times 20 divided by 60. Alright, always remember we have to change the minute into hour. Alright, and then plus 5, as we already found just now in the question A. And the last one, to find the area of trapezium C, is 1 over 2 times 30 plus 100. 30 is this side and 100 is the longer side here, and times 30, the difference in time is 30 over 60, change into hour. And so we get the answer is 54 1 over 6 kilometer. Alright, so now let's examples. Another example, okay, on speed time graph. Okay, so this speed time graph shows the movement of particle for a period of t seconds. Okay, the first question asks us to find the acceleration for the first 6 seconds. The second question B, distance travelled at a uniform speed. And question C, find the value of t if the average speed for the period of t seconds is 29 meter per second. Okay, so let's look at the first one. Okay, find the acceleration in the first 6 seconds. So we are going to find acceleration for the first 6 seconds only. So the first 6 seconds is here. Okay, so to find acceleration, that means we have to find the gradient of the graph. Okay, so as you can see here, okay, the change or the difference in value of y is 40, the difference in value of x is 6. And so to find the area, the acceleration, 40 divided by 6. Okay, or 40 minus 0 divided by 6 minus 0 is also equal. Okay, y2 minus y1 over x2 minus x1, and so you get the answer is 20 over 3 meter per second squared. That's the answer for the first question. Okay, so now let's do the second one, in which the question asks us to find the distance travelled at uniform speed. So uniform speed happens only at this place, okay, at this region. Okay, so to find the distance for speed time graph, that means we have to find the area under the graph. So to find area under the graph, what is the formula? Okay, so the formula is we have to find sorry, okay, I'm sorry. Okay, just recall that just now. The area under this graph, okay, will be 40. So the distance is 40 times 15 minus 6 is 9. So the answer will be 360 meter, because the unit here is meter per second and second. Okay, sorry. So now we go to the third question, which is find the value of t if the average speed, okay, for the period of t seconds is 29. Average speed, it is given average speed. So as we recall back, to find the average speed, that means we have to know the total distance and then we divide by total time. Okay, so for the first 29 second, or for the whole 29 second, you can see that we have a shape of trapezium here. Okay, to find the distance, we are going to find the area under the graph. So here, the total distance at the bottom line is t, total distance, total length for the top line is 9, and so the total distance for this graph will be 1/2 times t plus 9 times the height, which is 40. Okay, so that is the total distance over total time. Total time is t is equal to the average speed, which is 29. So now we can solve this question, this linear equation. We have 20t plus 180 is equal to 29t. And so we solve 29 minus 20, we have 90, and so t is equal to 20. So t is 20 seconds. That's the answer for question C. Okay, so now let's look at an example. Okay, this is examples of question from SPM 2003 paper 2. Okay, state the length of time that the particle move with uniform speed. So uniform speed, that means this region. So the question asks to find the length of time only. So the answer will be the time taken is 13 minus 6, which is 7 seconds. That's all. Okay, very easy and very direct question. Okay, question B. Calculate the rate of change of speed. So to find the rate of change of speed, that means you have to find the gradient. Okay, and the last 4 seconds only. So the last 4 seconds is this part. Okay, here is for the last 4 seconds, and so the length here or the height here is 18. Okay, so using the formula of gradient, y2. So let's say this is my y1, x1, y1, and here is my x2, y2. So y2 minus y1, which means 0 minus 18 divided by the time taken is 17 minus 13. Or maybe some of us that learn physics, we can use that to find the change in speed is final speed minus initial speed. Okay, laju akhir tolak laju awal. So yang bawah ni kena tolak yang atas, bukan yang atas tolak yang bawah. Okay, and so we have negative 18 over 4, or when we simplify we get negative 9 over 2 ms negative 2. So that's the answer for question B, which is finding the rate of change of speed. And the last, calculate the value of u if total distance, okay, total distance traveled in the first 13 seconds only. Okay, so first 30 seconds only, that means this is our first region, this is our second region. To find the distance, that means we have to find the area. So to find the area of the whole region, the first and the second one, the first one is a trapezium. So the formula will be 1/2 times u plus 18 times the length or the height is 6, plus the second region is actually a rectangle, in which 18 times with 7 is equal to 195, the total distance. So we solve this one, we get 3u plus 18 plus 3 is 54 and then 18 times 7 will be equal to 126, which equal to 195. So we solve this, we get 3u is equal to 195 minus 126 minus 54, which is 15. And u will be equal to 15 divided by 3, we have 5. So u is equal to 5. That's the answer for question C. And so that's all for this video. Don't forget to subscribe my video and enjoy learning mathematics. Assalamualaikum.